Okay, I think we are live. Good afternoon, everyone. Today we're going to be doing the chapter 2 of the Rust book. I want to actually be consistent in doing every chapter of this Rust book and having set times so people can actually join and understand that this is going to happen at a specific time. But I am very bad at timing and scheduling things. So I think at this point in time, I'm just going to leave it out into the open, and then maybe next week I'll put a set time after I have a couple of more chapters under my belt. Today we're going to be talking about a guessing game. I'm pretty sure you can see it on the screen. Let me see. Yeah. We're going to be talking about a guessing game. We're going to be programming a guessing game in Rust. So this is going to be our first kind of project, and we're going to be using the projects folder that we created in the last video. So let me see if I can pull it up for you. Positive. So this is our projects folder. Yep. So this is our projects folder. This is going to be our cargo folder, and then this is our hello world folder. This is our first cargo project, and every single project after that we're going to be using cargo and not Rust C. It's just so much easier. And just better. So we'll figure out the logistics of that. All right, come on. Nice. You're seeing everything on my laptop. This is my second YouTube video ever, so I wanted to tell you, like, my setup is a little bit better. I hope the audio quality can be fine-tuned in the future. It's not the best. I have a little microphone right here. So if the quality is not up to your standard, I am so sorry. We're just going to keep streaming until we get to high quality audio. Right? I do want to jump into this one because I think it's going to be pretty long. And I am excited. All right, let's go. All right, so let's jump into the Rust. Let's jump into Rust by working with our hands-on project together. This chapter introduces you to a few common Rust concepts by showing you how to use them in a real-world program. You'll learn about the let, match, methods, associated functions, external crates, and more. In the following chapters, we'll explore these ideas in more detail. In this chapter, you'll practice the fundamentals. We'll implement a classic beginner programming problem, a guessing game. So that's what we're going to be working on today. Here's how it works. The program will generate a random integer between 1 and 100. It will then prompt the player to enter a guess. After a guess is entered, the program will indicate whether the guess was too low or is too high. If the guess is correct, the game will print the congratulatory message and end an exit. Alright, so let's set up our project. We're creating a new project within our projects folder. And these are two other projects that we created, so we're going to create a new one called Guessing Game. To set up the new project, go to the projects directory, which we created in chapter 1. Please go back to that live stream. Like so, and then you're going to do cargo new, guessing game, and then CD into the guessing game. So we're going to open up a terminal in VS Code, which is the text editor that I use. So we're going to do cargo new. And the name of the project is going to be Guessing Game. Guessing Game, not Guess Game. And then we're going to create it. Let's wait. And CD into the Guessing Game project. Perfect. So now we're in. You can see our Guessing Game project appear. We have our source, our main RS file, our gitignore, our cargo.toml file as well. So these are our main things that we need. Now, the first command, cargo new, takes the name of the project guessing game as the first argument. The second command changes to the new project directory. So that's what we did. We just went to the project directory, which is guessing game. Alright, our file, cargo.toml, we're going to go to that file. You see we have 0 dependencies. I'm positive we will, let me see if we need a new dependency. As you saw in chapter 1, cargo new generates a hello world program for you. Check out main/rs.file. Okay. So yes, we're going to our main file. We went over this in the last one. But yes, it does a hello world and you can actually print this into your terminal. Okay, so they just want us to run a cargo run command. Oop. Alright, perfect. So right there, it says within my guessing game.exe, it generated a hello world. Okay. Alright. Perfect. We just tested our new project that we created, that's all. Processing a guess. Okay, the first part of the guessing game program will ask for user input, process that input, and check that the input is in the expected form. To start, we'll allow the player to input a guess. Enter the code in listing 2-1 into source.mainrs. So we're going to our source.mainrs folder. I'm going to take out this hello world function. Well, let's not take out the whole thing. We can leave most of it. Okay. So this is what we're doing. So we're going to use a standard input output. We're going to put that at our top. And we're going to import this. Standard input output module. Alright. Okay. So it gives you a whole slew of new code that we've never went over. But the best thing is it does go line by line and tells us exactly what's supposed to be happening. So let's kind of skip this for now and let's read on. So this code contains a lot of information, so let's go over it line by line. Perfect. To obtain user input and then print the result as output, we need to bring the input-output library into scope. So that's what we're doing at the top. Usually anything that you bring into scope, you'll put it at the top of your file. The input-output library comes from the standard library known as standard. STD. Okay, use a standard input-output library module. That's what you're going to put at the top. By default, Rust has set a set of items defined in the standard library that brings into scope of every program. This is called the prelude, and you can see everything in the standard library documentation. If a type you want to use isn't in the prelude, you have to bring that type into scope explicitly with the use statement. Using the standard.io library provides you with a number of useful features, including the ability to accept user input. Okay? That's really big, especially when you're prompting a user to put something into a text box within your program. So user input is a very important thing. All right, let's read on. As you saw in chapter 1, the main function is the entry point in the program. So function main. We have our function main. I didn't erase it, but this is where everything will be executed in the main function. Okay, the function syntax declares a new function, or FN syntax declares a new function. The parentheses indicate that there are no parameters, and then the curly brackets start the function of body. As you learned in chapter 1, println macro is macro that prints a string to the screen. So println and then whatever's in the parentheses will be printed in the terminal. And we've seen that when we do a println within our main function. Okay, this code is printing a prompt stating what the game is and requesting user input. So we're going to put a couple of things. We're going to do a println macro. Remember we just learned that whatever is in the parentheses will be printed to the terminal. So first statement is called guess the number. Oop, my bad. This is supposed to go after. Okay, and then the next println statement is going to be, my nails are way too long to be typing like this. Please, I think I'm gonna cut my nails because I need to be typing better than this. Your guess. Okay. Perfect. Okay, so this code is printing a prompt stating what the game is and requesting input from the user. Then we have to do our user input. We have to figure out how to store values. So this is storing values with variables. Next, we're going to create a variable to store the user input like this. So we're going to do a let statement, which stores, there's two statements, two things that you can store variables with. It's let and constant. And you'll see that constant is immutable. You can use let, and that is also immutable, but you can create a mutable a let. That's what we're doing here. So a let mute, and then guess, which is we're creating a mutable string. Okay, so we're going to mute guess. We're creating a new string. New. Perfect. Okay, now the program is getting interesting. There's a lot going on in this little line. We use the let statement to create the variable. Here's another example. Let apples equal 5. So this line creates a new variable named apples and binds it to the value 5. In Rust, variables are immutable by default, meaning once you give the variable a value, the value won't change unless, and here's the catch, you put it as a mutable variable. What? We'll be discussing the concept in detail in variables and mutability section in chapter 3. To make the variable mutable, we just add mute before the variable name. Okay. Lovely example. I think we get the gist. Returning to the guessing game program, you now know that let mute guess will introduce a mutable variable named guess. The equal sign tells Rust that we want to bind something to the variable now. On the right of the equal sign is a value that guess is bound to, which is the result of calling a string new. So a function that returns a new instance of a string. Now, the string is a string type provided by the standard library that is growable in UTF-8 encoded bit of text. Okay, so there's two types of strings, and we're going to be learning about strings in the it's thunder. I don't know if you can hear that thunder, but it's raining and thundering, which is the perfect time to study. So there's going to be two types of strings that we're going to be learning about. One of them is going to be like a ampersand symbol and then str, and this one is I call it a big string. So it's just a big S string. You know how to spell string. It's on the screen. Anyway, and that one is a growable string. So it's in two different areas. One's in a stack and one's in a heap, and we're going to be learning about that when we get to, I think that is chapter 4, when we're talking about references, borrowing, and all that stuff. It's very, very interesting. Something that is only a Rust concept. So, back to what we were saying. So this is a scrollable string, which means we don't know how many characters it's going to have. So it could be any amount of characters, and we have no idea. The compiler won't know until we actually get that input. So I'm just going to put scrollable string. And usually when I find something out, I have a new piece of information, and it has to do with the code that I'm writing or is relevant to my project. I just put a little comment, It helps me when I go back and look for a reference, helps me when I need it. Okay? Okay, so let's finish what we're saying. So the colon syntax is the new line indicates that new is the associated function of the string type. An associated function is a function that's implemented on a type in the case string. This new function creates a new empty string. Perfect for us, especially when we're, putting in information. You'll find a new function on many types because it is a common name for a function that makes a new value of some kind. I don't know why. I think my camera is a little bit in my way and I cannot read it. Okay, perfect. Sorry. Okay. Okay. This new function creates a new empty string, blah, 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 common name for a string, some kind of value. Perfect. In full, let mute guess equal string : new, and then our parentheses. This line is created a mutable variable that is currently bound to a new empty instance of a string. Phew. Perfect. So we got that line done. Next, we're going to be receiving input. So this is binding a variable to an empty string for user input. Perfect. Next, put that in there. Receiving user input. Now, recall that we've included the input-output functionality from the standard library with the useStandard.io. Oh, I need to put 2 dots. All right. So on the first line of the program, we call in the standard input function from the IO module, which will allow us to handle user input. So this is our IO module. So it's going to be like this. Okay. And you can put this on the same line. You don't have to put it underneath it, but you can. Now let's see what all this is actually doing. You know what I'm saying? Because it doesn't look very self-explanatory. So if you haven't imported the IO module, use standard IO at the beginning of the program. We can use the function by writing the function standard IO. Okay, standard input. The standard input function returns an instance of standard IO standard input, which is a type that represents. Okay, just tell me what's going on. All right. Next, the line dot read underscore line in my parentheses ampersand mute guess calls the read line method on the standard input handle to get the input from the user. So we're also passing the ampersand mute, which is a borrowed mute guess, as an argument to readLine to tell it what string to store the user input in. Okay, the full job of the readLine is to take whatever the user types into standard input and append it to the string without overwriting its contents. So it's just reading what it is and not overwriting it. And we're also, remember, we made this mutable variable named guess. So we're actually using it as a reference. So let's see. So therefore, we pass a string as an argument. So we're passing it as an argument within this standard IO, standard input module that we're utilizing. Okay. And then we're doing a read line, so it's reading what the user has already inputted into the terminal, and it's binding it to this, which is our variable guess. So now it's living in a variable at this point. Okay. The ampersand, did I finish this? Okay. The string argument needs to be mutable so that the method can change the string's contents. Yes. Okay. The ampersand indicates that the argument is a reference, which gives you a way to let multiple parts of your code access one piece of data without needing to copy the data into memory multiple times. References are a complex feature, and this is going to be a whole chapter. References are a complex feature and one of Rust's major advantages of how safe and easy it is to use references. And I'm pretty sure they're going to be talking about garbage collectors, and if you haven't heard about a garbage collector before, we can go and deep dive into it when we get to that chapter. You don't need to know a lot of those details to finish this program. For now, all you need to know is like variables. References are immutable by default, and hence you need to write a reference mute guess rather than just an ampersand and guess to make it mutable. So you're going to put it on the mute. Okay, chapter 4 is where they're going to be explaining references, which is going to be a fun little chapter. Handling potential failure with result. We're still... Oh, sorry. Sometimes you just need a little water break. Delish. Anyway. Let's get back to our little study. A little studying. Alright, so handling potential failure with result. We're still working on this line of code, so we're discussing a third line of the text, but note that it's still part of a single logical line of code. The next part is this method, the expect failed to read line. So expect is error checking, essentially. It will shoot you an error, which if we put that expect line, that is technically the error that we've created, and we want to see if anything fails, that should show up in the terminal. Okay. We could have written this code as IO standard input read line mute guess dot expect fail. However, one long line is difficult to read. Yes, so I was actually going to put this on the next line because it is a bit difficult to read. That's not fun. You could always, sometimes I do this. I just do the first one like that, and then I do any ones that are tacked on to the end of it in the next couple of lines. It just makes everything a little bit more readable. Okay. Yeah. It is often wise to introduce a new line or other white space to help break up long lines when you call a method with .method name syntax. Now let's discuss this line, what this line does. Okay, so let's put this in. let's do an expect, and we can put a different failure. You could be like, do like a try again, or you could do like just failed, or crashed. Let's put crash. I like that more. Okay. So, call method and method syntax. Okay, as mentioned earlier, read_line puts whatever the user enters into the string we pass to it, but also returns a result value. So result is a numeration, also called an enum, which is a type that can be in multiple possible states. We call each possible state a variant. Okay? And we'll talk about enums and structs and all that fun stuff in chapter 6. The purpose of these result types is encode error handling information. So results variants are okay and error. The okay variant indicates that the operation was successful and contains the successfully generated value, and then the error variant means that the operation had failed and contains information on how and why the operation failed. Values of the result type, like values of any type, have methods defined on them. An instance of result as an expect method that you can call. So that's what we used. We used the expect as one of the results or error types that we just talked about. If the instance of result is error value, expect will cause the program to crash and display our message, which we just put crashed. Display the message that you pass as an argument in expect. If the readLine method returns an error, it would likely be a result of error coming from underlying operating system. If the instance of result is OK value, expect will take the return value that OK is holding and return just the value to you so that you can use it. In this case, the value is a number of bytes in the user's input. Okay, if you don't call expect, the program will compile, but you'll get a warning. Sometimes it will panic, sometimes it will shoot you a warning, and the thing about Rust is that they have a very good compiler, and it gives you a lot of in-depth detail about what possibilities have crashed your program and may have caused it to panic, which we love. We love that. You can see how intricate this warning is. So you have the standard input output read line mute guess, and you can see use let to ignore the resulting value, let blah blah blah. So it's telling you to put it into a variable, a let variable. Essentially they didn't bind any variable to whatever this input output line is. It's not bind with anything. So it's telling you, Rust is warning you that you haven't used the result value returned from read_line, indicating that the program hasn't handled a possible error. Oh, okay. Maybe that's better than what my explanation was. The right way to suppress the warning is actually to write error handling code, but in our case, we just want to crash this program when the problem occurs. So we use expect. It's better than what I thought. I thought it was telling us that we need to bind it to something. But I guess in some way it is telling us to bind it to something. It's telling us to bind it to a result. So maybe I wasn't completely wrong. Anyway. Alright. Where are we? Printing values with println macro placeholders. Aside from the closing curly bracket, there's only one more line to discuss in this code so far. Okay? In this println, you guess the guess. Okay? And that little curly bracket that is in that print line macro is very important because it's going to print your guess. It says this line prints the string that now contains the user's input, and the curly set of brackets is a placeholder. Think of the curly brackets as little crab pinchers that hold the value in place. So we created our variable guess. We created our standard input. So it prompted the user, which is please input your guess, remember? Prompted the user within the terminal to put in a guess. We created a variable to hold that guess, that whatever guess that was created in that terminal by that person. And essentially the standard input output has read that guess, placed it in the variable, and we also have our expect, which is a result of either it crashing or being successful. Now we're going to print our guess. So we're printing our guess by holding it in these little curly braces, and it should print to the terminal, essentially. And we might be able to do a little check. I think the next part, testing is the first part. So we're going to do a little check after this to see if it's actually printing, okay? Alright. So, aside from the closing curly brackets, alright, think of the little curly brackets as little crab pinchers that hold the value in place. When printing the value of the variable name can go inside the curly brackets. When printing the result of evaluating an expression, place empty curly brackets in the format string. Then follow the format string with a comma-separated list of expressions to print in each empty curly bracket placeholder in the same order. Printing a variable and the result of the expression in one call to print line macro would look like this. Okay. Nice. Okay. So essentially what they're saying is, let's see. Sometimes when you read stuff and then you think about it, and you're like, what did I just read? I feel like that sometimes when I'm reading documentation. Okay. It's saying that the placeholders, so you can have multiple placeholders. It would have to be in a specific order though. But you put your placeholders or your curly brackets, and then you're going to separate them by using a comma and then putting that specific variable that you want in the placeholder. So yeah, that was a lot. You'll see that in other contexts, like in another project. But for now, we're just gonna leave it. We want to test our project. So let's do our print line. Print line macro. Oop, you guessed. And then I'm pretty sure we can put guess like this. I'm not sure why it's telling us to put it inside. Let's just try it. If it doesn't work, then don't listen to me. Okay, good night. Yeah. Okay, so there's another way to do it. You don't have to put the variable within the curly brackets. You can put a comma and then put the variable next to it. So that's what I usually do, and that's why I was a little bit confused on what it was saying. But you can even see it here with this print line. So it has X, I guess, in it, and then it has another placeholder, Y plus 2. So I guess you could do it in both ways. I think that's what it's saying, that this code will print X equals 5, and it will print Y equals 12, or Y plus 2 equals 12. Because you can put it in, or you can put a comma and separate it. See? The more you know. Okay. Let me see how long this is because I kind of want this to be a two-parter. How long has it been? I don't even know. Something like 35 minutes, which is perfect. I think I'm on time. I don't want to make these too long because then no one's gonna watch them. I guess it doesn't really matter. This is mostly for me. Okay, so we're gonna test. We just tested it. This is what it should look like. Guess your number. Exclamation point. Please put your input guess. Please input your guess. Me being dyslexic and then reading to you guys. Okay, and then I put my number, and you guess 9. At this point, the first part of the game is done. We're getting input from the keyboard and then printing it out. You can see it's obviously working pretty well because mine was successful, and I hope yours was successful, and I hope you're following along and doing this with me because the best method to learning is by doing. Yeah. But we're gonna take a water break. Sometimes when I'm reading too much, I just get a little thirsty. Alright. Our next method is generating the secret number. This is the fun part. Next, we need to generate a secret number that the user will try to guess. The secret number should be different every time so that the game is fun and fun to play more than once. So it should be random. We'll use a random number between 1 and 100 so that the game isn't too difficult. Rust doesn't yet include random number functionality in its standard library. However, the Rust team does provide a rand crate with said functionality. Now, increasing functionality with a crate. So remember that a crate is a collection of Rust source code files. The project we've been building is a binary crate, which is an executable. The rand crate is a library crate which contains code that is intended to be used in other programs and can't be executed on its own. So we're using it as a library and we're just borrowing some of this information. Cargo's coordination of external crates is where Cargo really shines. Before we can write code that uses rand, we need to modify the cargo.toml file and include the rand crate as a dependency. So open up that file now and add the following line to the beneath the dependencies section. Boom, dependencies. Section header that Cargo created for you. Be sure to specify rand exactly as we have here with this version number or code examples in the tutorial. Okay. Okay. I don't know how old this book is. I think it's 2021 or 2018. It might have been updated in 2021 because I know that there's a couple of them. Most of these dependencies are the same, so I wouldn't have any issue with that. But for the most part, if it is not working, you might have a different version, or you may need a more updated version. Whatever is the case, please look up and do your own research. And this is a book that probably hasn't been updated in a while. So it is a very good book, though, I would say, if you really do want to learn. And I haven't completely finished it, and I'm hoping that this series will help me finish it. Okay, I think we should do... Oh, it's going to tell us what to do. Sorry, I'm like getting ahead of myself. So in the cargo.toml file, everything that follows a header is a part of the section that continues until another section starts. In dependencies, you can tell Cargo which external crates your project depends on and which versions of those crates you require. In this case, we specify the RAN crate with the semantic version specifier 0.8.5. Now, Cargo understands semantic versions, sometimes called SEMVer. Interesting. Which is a standard for writing version numbers. The specifier 0.8.5 is actually shorthand for I don't know what that is. I don't know what that's called. I think power 2 0.8.5, which means any version that is at least 0.8.5 but below 0.9.0. I don't know. Cargo considers these versions to have public API compatible with version 0.8.5, and this specification ensures that you will get the latest patch release that will still compile with the code in this chapter. Oh. Any version 0.9.0 or greater is not guaranteed to have the same API as the following examples. Okay, that was a really good explanation. That was a little bit better than mine. So if your code isn't working because this book was made in 20-something, you might have a version that is greater than 0.9.0. So look into that. And you can look into documentation. And we will be talking about documentation and reading documentation very soon as well. So stay tuned. Now, without changing any code, let's build the project. So let's do a cargo build. Cargo build. That's what I was trying to do earlier, and then I noticed that it was telling me to do a cargo build. So that every time you add a dependency into your cargo.toml file, you're going to want to do a cargo build so that it includes it in your project. So that's what it's doing right now. All those dependencies, all those little things where it says compiling. I have no idea what they do. I just know that they get into my project somehow when I run that command, you know what I mean? Alright, you may see different version numbers, but they will all be compatible with the code thanks to the SEMVer. Yay, semantic versions and different lines, depending on the operating system. And the lines may be in a different order. Okay. When we include an external dependency, Cargo fetches the latest versions of everything that dependency needs from the registry, which is a copy of the data from crates.io. Crates.io is where people in the Rust ecosystem post their open source Rust projects for others to use. If you've never seen Wraith, actually, let me just pull it up for you, okay? Crates.io. This is a little place where all these people upload their open source dependencies. If you've never been in here, it's nice. Take a little gander, you know what I'm saying? API bindings, web programming, no standard library. They have a lot of fun stuff in here. Especially when you need something specific, they have some documentation talking about what release it is and what version, what it does, how to use it. Look, example derive macro. They have perfect examples on here. Spans and erroring reporting. When you're using documentation within your as research for your project, then this is a really good place for you to look into. And also there are documentation for Rust specifically within Rust programming. I think it's within this website, the Rust.lang. Usually I just look up let's say Axum documentation Rust, and it will take me straight to that website. So you can just Google that. Just Google that shit. Yeah, I found out that I can curse in YouTube videos. Isn't that lovely? I didn't know that. So, the more you know. Where am I? Okay, after updating the registry, Cargo checks the dependency section and downloads any crates listed that aren't already downloaded. In this case, although we had listed RAND as a dependency, Cargo also grabbed the crates that RAND depends on to work. After downloading those crates, Rust compiles them and then compiles a project with the dependencies available. Done. If you immediately run cargo build again without making any changes, you won't get any output aside from the finished line. Cargo knows it's already downloaded and compiled the dependencies, and you haven't changed anything about them in your cargo.toml file. So Cargo also knows that you haven't changed anything about your code, and it won't recompile it either. With nothing to do, it simply exits. So don't do it again. It's not going to do anything. If you open the source.main RS file, make a trivial change, and then save it and build it again, you'll see 2 lines of output. Compiling guessing game, and then finish dev profile. These lines show that Cargo only updates the build with your tiny change from source.main RS file. Your dependencies haven't changed, so Cargo knows it cannot reuse what it has already downloaded and compiled for. Perfect. Alright, ensuring reproducible builds. And let me just make sure I know where we're stopping. Okay, we're going to stop at generating random number, and we'll pick up tomorrow. I don't know what time. Let's just finish up and then I'll think about it. And I might even put it in my bio when I figure out a good time, because I am very bad with doing things on time. So maybe this will make me a little bit better. Okay, ensuring reproducible builds. Cargo has a mechanism that ensures that you can rebuild the same artifact every time you or anyone else builds your code. Okay, Cargo will use only the versions of dependencies you specified until you indicate otherwise. For example, say that next week version 0.8.6 of RAND crate comes out, and that version contains an important bug fix, but it also contains a regression that will break your code. Interesting. To handle this, Rust creates a cargo.log file, and the first time you run your cargo build, so we have this guessing game directory. Wait, what? Oh, creates this the first time you run the cargo build. My bad. I thought there was more explanation. When you build a project for the first time, Cargo figures out all the versions of the dependencies that fit the criteria, then writes them to the cargo.log file. Now, when you build a project in the future, Cargo will see that cargo.log file exists and will use the versions specified there rather than doing all the work and figuring out those versions again. Yeah, she's smart. Now, this lets you have a reproducible build automatically. In other words, your project will remain at 0.8.5 until you explicitly upgrade it within your cargo.toml file as well, thanks to the cargo.log file. Because the cargo.log file is important for reproducing builds, it's often checked into source control with the rest of your code in your project. Alright, this is our final paragraph. I don't know. I knew I was going to be talking a lot, but sometimes it's a lot to read. So hopefully I get better at my reading, because I know I do skip over some words, and hopefully everything just it keeps elevating and getting better, and I hope that this stream actually has an audience at one point. Somebody actually joins, because no one has joined so far. My chat is empty. Let me show you my chat. It's really bad. Oh, I didn't even sign in. Welcome to live chat. Am I supposed to sign in? That's a later problem then. I don't need to be doing that right now. Alright, let's finish. Updating crate to get a new version. when you do want to update a crate, Cargo provides the command update, which will ignore the cargo.log file and figure out all the latest versions that fit the specifications of cargo.toml. Cargo will then write those versions into the cargo.log file. Otherwise, by default, Cargo will only look for versions greater than 0.8. What the heck? What's about all these numbers? 0.8.5 and less than 0.9.0. In the RAN crate if the RAN crate has released the two new versions, 0.8.6 and 0.9.9.9.0, you will see the following in your cargo.update if you ran that. Okay, do you want to run it? Let's do it. Let's do a cargo update. 0 packages, the latest Rust 1.93.1 compatible versions. Okay, interesting. Okay, so Cargo ignores the 0.999.0 release. At this point, you will notice that the change in your cargo.log file, noting that the version of the RAN crate you're now using is 0.8.6. To use RAN version 0.999.0 or any version in that series, you will have to update that cargo.toml file to look like that instead. Don't actually make this change because the following examples assume that you're using the RAN 0.10. Okay, the next time you run the Cargo build, Cargo will update the registry of crates available and reevaluate your RAN requirements according to the new version you've specified. Now there's a lot more to say about Cargo and its ecosystem. We'll discuss this further in chapter 14. For now, that's all you need to know. Ominous. Cargo makes it very easy to reuse libraries, so Rustaceans like you and me are able to write smaller projects that are assembled from a number of packages. And we're going to leave it here today. Tomorrow, we're going to be talking about generating that random number and finishing up this project. I'm trying to be consistent all week. This weekend was a very difficult one. I want to do more on the week than on the weekend. It was just very difficult. I had a lot of people at my house and I was not going to be able to stream at all. So, sorry for that delay. I'm glad we can do this. It's Monday. I'll see you tomorrow, hopefully at a good time. I'll try and make a time so that we can meet and hopefully actually people join, because right now I have 0.0 followers. But I'll see you next time. Yeah. You have a nice day.